All right, welcome you guys. So let's go ahead and talk about our last conic section, the hyperbola. Okay, so hyperbola, basically, at least the ones we're going to discuss in this class, are either going to open left and right, open horizontally, or they're going to open up and down. So they'll open vertically. And it's kind of like two parabolas facing the opposite way of each other. And there are similarities, like we still call this the vertex together, the vertices. So this would be a vertex and this would be a vertex, the plural being vertices. Okay. So the distance from the center to a vertex is still going to be the letter A, just like it was with ellipses. And then we're actually going to have a foci again. The foci are going to lie inside. By the way, these little parabolas are actually called branches. So they're going to lie inside each branch of the hyperbola. And just like before, the distance from the center all the way out to a focus is going to be called the letter C. So lots of similarities to ellipses, luckily. Okay. And then this distance, I don't know if you'll even need this, but what the heck? This distance, the line segment between the vertices, that's called the transverse axis. You can see that that's defined there. Okay. All right. So those are the two types. Either it opens horizontally or it opens vertically. Now here are some formulas. These are very specific. We're going to encounter more general formulas in a second, but these are the formulas when we're centered at the origin. Okay. So let's just kind of look at some things. This looks almost exactly like the ellipse. The only difference is the minus is a plus. Same thing over here. This is different in that, I'm sorry, yeah, that there's a minus here instead of a plus, but now y squared is first here. So those are some differences. For hyperbolas, it'll always be a minus. If you come over here to the foci formula, there's a difference there too. It's a squared plus b squared equals c squared. So for like my memory and stuff to help, I always think whatever sign is right here, it's going to be the opposite in the foci formula. And that really helps me. Okay. All right. And then down here, we have something new. We're going to have formulas for some asymptotes. So if you look at the picture, we've got these dotted lines that are kind of guiding the hyperbola. It's going to come out and get closer and closer to that asymptote. Same thing down here. Well, these are the equations to find those lines. The only difference between the two is if we open horizontally, if we open in the x direction, then it's going to be b over a. And then if we open vertically in the y direction, then it's going to be a over b. And that's just the slope. You can see on this particular problem, we went up b, and then we went over a. You can see that from right here. So the slope should be b over a. On this one over here, we went up a and then over b. So it just has to do with the slope of that line. Another trick a teacher taught me that's a pretty good trick is for slope. If you go back, when we learned that section, it's always the y over the x. Oops. So if you go back and you look at the original, whatever's underneath y, in this case b, is going to be on top, and whatever's underneath x, in this case a, should be on bottom. That's why we put b over a. If we go over to this other one, whatever's underneath y should be on top. So now a should be on top. And whatever's underneath x should be on bottom. So b should be on bottom. So that's why it's a over b. So if you just remember y should always go on top when it comes to slope, just like the slope formula, then that will help you remember whether it's going to be b on top or if it's going to be a on top. All right, you guys. So let's go ahead and look at these next examples. So this is just comparing an ellipse. We know this is an ellipse because it's a plus. And the only difference over here is that this one has a minus. So just that one little change makes quite a drastic difference in the picture. Okay. The box is still the same, this red box throughout all of these. And that's basically, remember that this is a squared, the 9, so a would be 3. So we went 1, 2, 3 in the x direction. The square root of 4 is 2. So we went 1, 2 in the x direction, and that's how we get this box. Well, the same thing over here. It's the same box. The square root of 9 is 3. So I'm going to go 3 in the x direction. Square root of 4 is 2. So I'm going to go 2 in the y direction. Draw my box. And same thing over here, even though this one looks so drastically different. The reason why it's still the same is because 9's still under x. So I would still go 3 in the x. And 4 is still underneath y. So I'd still go 2 in the y. Now, if the x is first, that's what's going to make it open in the x direction. That's what's going to make it open horizontally. If the y is first, then that means it's going to open in the y direction, aka vertically. So that is the main thing that you're going to be thinking about with hyperbolas is who's first. With ellipses, it was who is biggest. Since 9 is bigger, we know it's going to be bigger in the x direction. But look, on this one here, the 9 being bigger had nothing to do with it. It has to do with who's first. Since y is first, that's why it opened up and down. Okay, and we actually took the smaller number 2 to get to the vertices on that. And that's basically what this is saying right here, you guys. So this rectangle that we draw, we didn't draw it for ellipses, but we're going to draw it for hyperbolas because we're going to draw the asymptotes through the diagonals of that box, which by the way, it's called the reference rectangle. And then we'll be able to sketch. Without that box, we wouldn't know, like let's say that without the asymptotes, we wouldn't know how wide to make our hyperbola. Because let's say we had our box, well, do I make a really wide hyperbola or a really skinny one? So what's going to help us determine the width of the box are those asymptotes that go through the diagonal of the reference rectangle. Okay, so let's go ahead and look at our first example. All right. So the main thing to note is that a squared is first with hyperbolas. It's not necessarily the biggest. I purposely chose this example because 9 is actually smaller than 25, okay? So a squared is going to be 9. So if we square root that, we get a equals 3. That must mean b squared is going to be the 25. You square root that, you get that b equals 5. And same as before, you have to look, okay, this a was under y. And then this b squared, was under x. So we're going to go 3 in the y direction once we figure out what our center is. So our center in this case is 0, 0 for the same reasons as in the last section. If you see nothing with the x and the y, then you're looking at 0, 0. Just to give you examples where we have something with the y and the x, this one would no longer be 0, 0. Okay, just so you look at the difference between the two. All right. So in order to find the vertices and the foci, you're going to take that center, 0, 0. And because the y is first, all the action is going to be happening to the y value of the center. So we're going to have 0 plus or minus a. And here we'll have 0 plus or minus c. I'm writing that down because I just want to make sure that we understand a is always for the vertices and c is always for the foci. Okay, so now we'll go ahead and we'll put those in. So we already found a. A was 3. So this is going to be 0 plus or minus 3. So 0 plus 3 would be 3. And then 0 minus 3 would be negative 3. Now, the thing we haven't found is the c yet. So let's go ahead and take our foci formula. Now, remember, it is a squared plus b squared equals c squared. The tip for ourselves is it's always the opposite of whatever's right there. Okay, so a squared, we got it. It's 9. B squared we had was 25. So we get 34 when you add those together. We're going to go ahead and square root both sides to get rid of the squared. And I don't think the square root of 34 breaks down, but let's go ahead and check and see here. So let's see, 34. Yeah, it's just 2 times 17. Those are both prime already, huh? So no doubles, okay? I should probably get my calculator out here. So let me do that. Sorry, bajillion things open, you guys. There we go. Okay. So I like to get the square root of 34 estimated just for graphing purposes. So square root 34, and then this 5.8-ish. Oh, 5.8. I'm not going to use that when we put this into my math lab because we round it and that would not be exact. Okay. All right. So let's go ahead and plug that in to our problem. So it's going to be 0, 0 plus or minus root 34. And so that's just going to get you 0 root 34 and then 0 negative root 34. 0 plus root 34 is root 34. 0 minus root 34 is the negative part. Okay, so we got all this stuff. We just got to go graph it. So we know that the center is 0, 0. Now we're going to go 3. I should probably erase this off. We're going to go 3 in the y direction. So I'm going to go up 3. I'm going to go down 3. And then we're going to go 5 in the x direction since it was under x. So we're going to go 5 to the right, 5 to the left. And we're going to draw our reference rectangle, okay? So we're going to draw, let me make sure the color is black. It is, okay. We're going to draw a line here. It's basically a rectangle where those dots are along the edges. And then we're going to draw through the diagonal of the rectangle. Just this, but my twister. There we go. It's a little bit off the screen. Perfect. Okay. So now because y is first, we are going to draw this in the y direction, you guys. So we're going to have a really wide branch up here. And we're going to have a really wide branch down here. Now, we said that the vertices were going to be at 0, 3, 0, negative 3. You can see that this is going to be 0, 3 right here. And then this one is going to be 0, negative 3. And then if we were to go to the foci, remember we said square root of 34 is about 5.8. So 0, 5.8, 3, 4, 5. One focus would be here. And 4, 5.8, and the other focus would be there. They should always be inside the branch, like this little kind of parabola looking thing should be opening up with it on the inside. So everything looks pretty good here. So now we just have to get the equations for the asymptotes and we're done. So for the asymptotes, okay, remember that if we said that it's basically going to be, slope, and slope is always the y over the x. So the formula is going to be, in this case, a over b x. You can just go and look it up. Let me show you how to do that really fast. So since we open up and down, we're looking at this type of a hyperbola, okay? And you can see right here are your formulas for your asymptotes, okay? So there's that. We said another way to get it, if maybe your teacher doesn't allow a note card or something and you have to memorize, is to basically just always make sure that you square root what is underneath y and you put that on top, and you square root what's underneath x and you put that on bottom. So if we did that, I like that way. The square root of 9 is 3, and the square root of 25 is 5. So that would be our asymptotes, and we can always check in our picture, right? So the y equals mx plus b, the b is 0, and we do go through 0. And look, we go, the rise is 1, 2, 3, and the run is 1, 2, 3, 4, 5. That's going to be the positive one because it slants towards the right. Then if we go up 1, 2, 3 to the left 5, that's what's going to give us the minus case. So the reason we have that plus or minus on there is because one of them slants towards the right and has positive slope, and one of them slants towards the left and has negative slope. Okay. If you have a graph, you could just get it straight up from the graph. Okay. The reason we have these formulas is because sometimes, not when we're centered at 0, but when we have other centers, this y-intercept is not pretty. It goes through a fractional spot, and you can't on your graph know, is that a third? Is that a fourth? So we have to have these formulas to make sure that we can get accurately the answer. All right, let's try some more. Okay. So these are going to be the more general formulas. So if I was making a note card for my class, I would just write these down because they encompass all cases. If you were centered at 0, 0, you could just let the H and the K be 0, 0, and you'd have the other formulas. Okay. So the foci formulas over here, it's still the same. Okay. It's still going to be B over A if it opens up in the X direction, and A over B if it opens up in the Y direction. One of the things that's helpful if you have to memorize for your class is that I don't really memorize this. It's already, I just kind of steal these parentheses up here. It's those exact parentheses that were given to you in the directions in both cases, right? Y minus K, X minus H. So that's kind of how I think of it quickly, is just to steal what's in the original problem, guys. Yeah. Again, if we open in the X direction, then everything is happening to the X value. The Y value is left alone. It's happening to the X value. The Y value is left alone. If we open in the Y direction, now it switches. Everything's happening to the Y value, and the X value is left alone. So that it all just works really nicely. Okay. All right, so let's try one that is not centered at 0, 0. All right. So a squared is always the first number. So it's not 9 because 9 is bigger than 7. It's 9 because 9 is first. Ooh, they didn't give us a pretty one this time, huh? This will just be the square root of 7. So that's got to be 2 point something. Let's go see. Square root of 7. 2.6-ish, we'll say. I'm only getting that number so I can graph it. Okay, so it's good to note that this A is under Y, oh no, under X, just kidding. And that this B is under Y. So that tells me, once I get my center, that I'll be going 3 in the X direction and 2.6 in the Y direction. Okay, so the center is pretty easy. You guys have been doing it, honestly, all semester long when we did circles at the beginning of the semester. You always change the sign of whatever you're pulling out of parentheses. So this is going to be 4, -3. So that's going to be the center for this hyperbola. So we already know we're going to go 3 in the X direction. So 1, 2, 3. 1, 2, 3. Then we know we're going to go 2.6 in the Y direction. 1, 2.6. And then we're just going to draw our reference rectangle. Oh, I don't even know what that was, you guys. I was off a little bit on that, huh? Left-handed issues. Okay, let me just go ahead and try to move that guy over really fast. Oops. Is it gonna let me? Ooh, it's making me select the whole thing. No. Okay. Let me just do this then. There we go. Sometimes I like to just draw these. When I'm on paper, I just draw them by hand. But I don't know if you work with a device like this, it makes your writing look so much worse. Okay. All right, now I'm going to go ahead and draw my diagonals. Okay, so now we have to determine if this is facing up and down or left and right. X is first. So we're going to be opening in the X direction. In other words, we're going to be opening left and right, horizontally. So we could get our vertices just from the picture, you guys. That would be perfectly fine. Like it looks like this vertex is at 1, -3. And then it looks like this vertex, right here is at 1, 2, 3, 4, 5, 6, 7, -3. Okay. But we should get that when we do the math. So let's see here. We got to get the vertices. Now remember, you take the center, and because this opens in the x direction, I'm going to add and subtract a to the x value. As it opens in the x direction, I'm going to add and subtract c to the x value of the center. All right, so a we already have, it's 3. So we've got 4 plus or minus 3, comma, negative 3. So 4 plus 3, 7. And 4 minus 3 is 1. Hey, I recognize those numbers. Those are the ones we just said. All right, so we still have to go in and get our c. So a squared plus b squared plus c squared. And we already found a squared and b squared. Ooh, I like this number, 16. I'll take it. Because then when we square root, we'll get a nice perfect number. C equals 4. Cool. Okay, so we're going to go ahead and do 4 plus or minus 4, comma, negative 3. So that means that we're going to have 4 plus 4 would be 8. And then 4 minus 4 would be 0. Let's go make sure that these make sense. So 0, negative 3 would be right here. That is inside the hyperbola, so that looks good. And then 8, negative 3 would be also inside. So these are looking really good. Okay. So the last thing to get is the asymptotes. All right, so it's y minus k equals plus or minus. All right, so we just have to figure out if it's a over b or b over a. Since the x is first, this looks like it's going to be b over a. Just go back to the last slide. If it's facing sideways, then it's b over a. If it's facing up and down, then it's a over b. Okay, that's for people who have a note card. If you don't have a note card, the easiest way is steal these parentheses. So it's going to be y plus 3. Steal this parentheses for the x part. And we already said we know slope is the y over the x, right? y2 minus y1 over x2 minus x1. So I'm going to take the square root of 7, since it's underneath the y. And I'm going to put that on top. And then I'm going to put the square root of 9, which is 3. I'm going to put that on bottom. So it's always going to be the y1 over the x1. Okay. And that goes along with what this formula says. The formula says put b over a. Use root 7. A is root 3. Or is 3, sorry. And that's it. Those are going to are really super ugly. I'm not even going to get into like trying to see if those are accurate because it's just such a bad example. But I put it into my math lab like that and it accepted it, you guys. So we are good to go for those of you that are using my math lab. I think we got everything. Graph it, identify the center, vertices, foci, and equations of the asymptotes. We are looking good. All right. So now we have to work on how do we get it into that form? It's not always going to be given to us like that. And I gave you a particularly tough one here. Okay. I think a lot of us would want to put the x's first. Okay. So like we would probably group these x's together, etc. But what I'm going to say is because the x, it has a minus in front of it and the y squared has a plus in front of it, that what we're going to want to do is we're going to want to put the y's first. And then we'll put the x's second. And let me see if I can explain why well enough to where you guys will understand. When you have a hyperbola, it's either, x minus h squared. There's a minus between. Or it's the y that's first. All right, this is so sloppy. I'm just going to erase these. I'm writing down the two formulas for a hyperbola. This is never negative, the front number. The negative is always right here in between the two. And so that's why we put this y first. It's not negative. But this x squared that is going to be negative, that's going to translate, well, not to that minus. It'll actually translate to this formula right here, where we'll have a minus right in front of the x being squared. Okay. So, and if you didn't do it, you could always switch it out in the end Okay. You might end up, let me just like, give you an example of one. You might end up with like something like this. Okay. And you're like, wait a minute, that doesn't look like any of the conics that we've had. And so then you just pull a little switcheroo at the end and you're like, oh, well, what if I put this y squared first? And then I put that x squared second. Okay, now it's starting to shape up to look like a hyperbola. Okay. So you can always move it at the end. I'm going to just move it here at the beginning so I kind of already know where it's going. Okay. But it's up to you guys. Sometimes you might end up doing it this way because you forgot. Okay. And that's totally fine as long as you see it in the end. Okay. So you're always going to factor out the leading coefficient. Don't factor out too much. Don't factor out the GCF. You just want to take out the 5 here. Yeah, they have a y in common, but that's not what I want to pull out. So 5 goes into 80, I think 16 times. And here I have to pull out a -4. Don't just pull out a 4. I'd say that's one of the main mistakes people make, is they end up keeping this sign a minus. But remember, if you pull out a negative, it's going to change the sign. 4 goes into 40 10 times. Now remember, don't be afraid, you guys, to redistribute. Man, that's going to catch so many mistakes. Just do it in your head, right? Be like, okay, there's my 5y squared. There's my -80y. That one looks good. There's my -4x squared. There's my -40x. That one looks good. Okay. All right, so now we're going to use that formula for completing the square twice, right? So we have to take half. Let me actually get this more out of the way. We have to take half of b and square it. So the first b that we're going to use is that -16. So half of -16 is -8. And -8 times -8 is 64. Now, if you watched my other video, you know, don't put a plus 64 here and a plus 64 here. You actually have to multiply 5 times 64, which I think is 320. Okay, that's what you're going to add to the other side. Okay, 320. All right, let's try it again, but this time with our other b, the b for the x's. So we have to take half of 10 this time. So half of 10 is 5, and 5 squared is 25. But I didn't really add 25. I really added -4 times 25. So actually I subtracted 100 from that side. So I'm going to subtract 100 from this side as well. And then we said, don't work too hard when you're factoring these. Okay. The answers to how they're going to factor lie inside the parentheses over here. So for the first one, we're going to drop this -8 in right here. So it's going to be y -8, you guys. And then for the next one, we're going to take this 5. We're going to put it in right there. It's a +5. So this is going to be x plus 5. And you can tell that works because -8 times -8 is 64. The -8 plus -8 is -16. 5 times 5 is 25, but 5 plus 5 is 10. So we indeed got the correct factorization. All right, if we take these numbers and we add them all up, it just leaves us with a 20. Now we know that the formula does not look like this. There's always a 1 over here. Because there's always a 1, we're going to have to divide through by 20 to make that 1 happen. All right, so we've got y -8 squared. And you can see that 5 goes into 5 once, 5 goes into 24 times. So this is really going to have a 4 in the denominator. I'm not going to write the 1. Then over on this one, 4 goes into 4 once, 4 goes into 25 times. I'm not going to write the 1, but I will write the 5. Okay, so that is our equation of our hyperbola. You know what? I know it didn't ask us to, but I'm going to go to the next level and get a few things because this one's kind of tricky. I'm going to get the center. I'm going to get the vertices. So the center, a lot of students make the mistake of putting 8, -5. And also I did, not gonna lie. So, but you have to put the X first, you guys. So make sure that you write the -5 first and the +8 second. Don't forget to change the signs, okay? I wanted to point this one out because I feel like that's the mistake students make a lot of times. And then remember, everything's going to be happening to the Y value because Y is first. Okay? So everything's going to be happening to the Y value. So A, in this case, well, A squared is 4. So A must be 2. So I'm going to, and B squared is 5. So B must be square root of 5. Okay. But let's go ahead and put the A in. So this is going to be -5, 8 plus or minus 2. So -5, I'm sorry, yeah, -5, 8 plus 2 is 10. And then -5, 8 minus 2, 6. So those would be our vertices. And then we would just have to pull the A squared plus B squared equals C squared. Figure out what our C is. So let's see, we would have 4 plus 5. Ooh, that's nice. We got a 9, right? So we square root both sides. We are looking at C equals 3. So we substitute that in. We've got -5, 8 plus or minus 3. So -5, 8 plus 3 is 11. -5, 8 minus 3 is 5. So that would be our foci. And I'll just get really quickly the asymptotes the way that I do it without a formula. So remember, steal the parentheses. It's a Y minus 8. Steal the parentheses of X plus 5. And then remember to put whatever's underneath Y, square root it. So that's a 2. And then whatever's underneath the X, square root it. And I'm going to leave that. I don't know if you'd have to rationalize the denominator and what your textbook requires. I'm pretty sure this is good for my math lab. I don't know if they give you one with the square root in the denominator, to be honest. But good enough is what I'm going to call it. Okay. Hopefully you're getting a little bit better at each piece, you guys. So Y was first, so that's why all the action happened to the Y. Okay. Determine the standard form of the equation of a hyperbola with vertices, blah, 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 and asymptotes, blah, blah. Okay. All right, so I'm going to draw a little picture. It kind of helps me, you guys. So -3, 0 is one vertex. And then 3, 0 is the other vertex. Okay, so what I want to ask myself is, well, what do I know because of that? Well, I know a lot. For example, I know the center is 0, 0. Also, the distance from the center to a vertex is the letter A. So I know that A equals 3, which implies A squared equals 9. I claim I also know which of the formulas I'm going to use. So it's centered at the origin. So it could be X squared minus a Y squared. And A is always first. So don't think too hard about that. Or it could be Y squared minus an X squared. Okay. Well, since the vertices are these dots they gave us, I know that this opens horizontally, left and right, which means X should be first. So I even actually know which formula. Look how much information we got off of just 2 points, right? Very cool. So let's start filling them in. So we've got X squared. We know A squared is 9. So all we're missing, you guys, is the B squared. All right, so let's go look at what else we know finally. They gave us the asymptotes. They gave us that the asymptotes are those, right? Well, we know that if X is first, that the formula for the asymptotes, if it's centered at the origin, right, is going to be B over A. And you could just look that up, or you could just look over here and see that we would have to square root the b because it's underneath the y. Y always goes on top with slope, right? And so b should be on top, and then the a is underneath the x, so that should be on bottom. So always y over x, right? By 2 minus y1 over x2 minus x1. Yeah. Now what I'm going to do is I'm going to take just the slope part of both, and I'm going to set them equal to each other. So we know that b over a should equal square root of 3, and I'm going to put it over 1. And it's because a lot of times you're not just going to have a single number like this. You will have a fraction. So I want you guys to cross multiply so you get used to that. So that's why I put it over 1. Okay, we know a, you guys. So we're going to fill a in. Okay. So we're going to take the fact that a is 3 and then drop it in right there. And then we'll cross multiply. On this one, you could have done other ways besides cross multiplying, but I'm going to do it just so that you get used to it. All right, b times 1 is b, and 3 times root 3, well, that's 3 root 3. Now we do have to square this though, because what we're missing in the formula is b squared, right? This is what we're missing. So we have to square it. So if we square that, we find out that b squared equals, well, we have to square each piece here, you guys. So we have to square the 3, which is 9. And we have to square the square root, which is going to undo it. So we're just going to get 9 times 3, which is 27. So we have our formula for this particular hyperbola. All right. I think we're on our last one here. Yes. Okay. Find an equation of a hyperbola satisfying the given conditions. All right. I'm going to draw it again, guys. So 0, 3. Those are the vertices. And then we have foci at 0, 5. I put an X so I can tell the difference. Okay. So, I mean, we know a lot, right? We know that our hyperbola must look like something like this, right? Okay. All right. So that tells me that y is first. Now it looks like we're centered again at 0, 0. So I'm going to use this formula. Okay. All right. And then we know a few letters, huh? They gave us a again. A is going to be 3. So that implies that a squared is going to be 9. So we might as well substitute that in. Now we're missing the b squared again, but we're going to get this in a totally different way. Okay. So we can see that we have the letter C. C goes to the foci. So we know that C is 5. That's going to imply that C squared is going to be 25. So this time to get the b squared, instead of a proportion and cross multiplying, we're going to use a squared plus b squared equals c squared. 9 plus b squared equals 5. We're going to subtract 9 from both sides. B squared equals 16. And you know what? I always used to accidentally square root this and find b. But remember, it is b squared that we're missing. So we're actually just going to leave it like that. So it's kind of weird, huh? And we have our equation. So this is a very formula-based section. Like, whew, probably of all the chapters we've done this semester, the one with the most formulas. So making sure that you make a good note card for this is going to be key, right? Because if it's good, then you shouldn't really struggle too much, okay? And maybe some of these tricks I've taught you, like if it's in the y direction, y's first, or especially for the asymptotes, because those can be kind of hard. The whole, well, you just steal the parentheses and then make sure you square root what's under y and put it on top. That type of stuff will be helpful too. All right, you guys, good luck on the homework, and thank you so much for joining me.